Hey everyone, thanks for joining us here. We are doing an AMA with useful sensors and Edge Impulse, and I'm excited to learn a lot of stuff I don't know about useful sensors, which is a really new company. And of course, Edge Impulse, we've been working with here at SparkFun for quite a while now. But let's start by introducing all the players. Pete, why don't we start with you?
Awesome. Yeah. No, thanks, Rob. Yeah, it's really great to be here. I used to be the lead of TensorFlow Lite Micro at Google, working on embedded machine learning there, where I worked with Dan while he was still, before he headed off to Edge Impulse, and we actually did a book together. And now I'm starting something new together with my co-founder Manjunath, who's also on the call. And I'm really interested in hearing all your questions and seeing which ones we can answer.
Daniel, go ahead.
Cool. Yeah. So I'm Dan. I'm the head of machine learning at Edge Impulse, which, as Pete mentioned, is where I headed after working at Google and working on TF Lite Micro with Pete. So super excited to be here. It's always really cool when a new type of product launches, and that's what Pete's company is building. So really excited to help share the word.
Cool, Manjunath.
Hi guys, I'm a co-founder and the CTO of Useful Sensors. And before that, if a tiny ML is anything to do with like the size of the chip that is running those ML programs, my previous job was really like the biggest ML, right? I was working at this company called Cerberus, which was doing the largest chip for accelerating machine learning. But before that, I was at Google on the TensorFlow team, working on TensorFlow, the earliest tools, and also worked a lot with the Pete on device ML. And I'm excited to be here. It's my first live streaming thing, so if you find me nervous, the reason is that.
Cool, and Jan?
Hi, I'm Jan, co-founder and CTO at Edge Impulse. Yeah, it's interesting. Like the first thing the way I always was like, well, previously I was at ARM actually, but we've been at Edge Impulse for 3.5 years already, and it just has gotten way bigger than anything I ever envisioned while at ARM. Edge Impulse is a leading developer platform for tiny machine learning and embedded machine learning in general. Every day, over 300 new projects are being created, which is just astonishing. But a lot of these are, developers doing things. And as we all know, there's a really big step from 0 to 1, and then from 1 to 10,000, and actually taking the stuff into production. So, yeah, I'm really excited to learn from the Useful Sensors team on what does it actually take to go, beyond just one prototype and actually selling something with a model that actually is going to work and generalize in the real world.
Great, thanks everybody. So let's start out with, I guess, the obvious first question. Pete, what led you to create Useful Sensors? What was your inspiration behind it?
So it was really from my conversations with manufacturers. So I started becoming interested in TinyML because I saw all these possibilities for really neat things that you might be able to do with it. Like I really want to be able to look at a light switch and say on, and just have the gaze detection and the voice recognition just kind of work out of the box and have the lights go on, or have my TV pause when I get up to get a cup of tea without me having to kind of fumble around for the remote. But when I talked to light switch companies, TV companies, appliance companies, I would tell them all about this wonderful open source framework that you could get your hands on for free, and all of these great sort of documentation and all of these other things they could use. And at the end of it, they would often sort of look at me and say, look, we only have a few software engineers, they're all super busy, we definitely don't have a machine learning team, we're not planning on doing our own sort of R&D around this. Can you just give us a voice interface, or can you just give us a something that tells us when somebody sits down in front of our TV? So after hearing that for several years, it finally kind of, I finally took it on board. And really what we're trying to do with useful sensors is just create something that solves that problem for people building things, where they just really want to have some ML capabilities, but they don't want to, train their own model. They just like to really use something off the shelf to do some common things like person detection, gesture recognition, voice recognition, things like that. And obviously I've worked with, the maker community for years. It's been fantastic. So I was really excited to get what we're building out into the hands of people who are really creative, and see what they come up with.
Great, I love that. For those of you who might not be aware, Useful Sensors has created their first board, and it is a person sensor. This is a $10 person detection sensor. $10, y'all. And this is your first board. Why don't you tell us a little bit about it?
Yeah, so really when we thought about, okay, what do people who are building things need? Like, what are they comfortable working with? I realized that, almost every maker and manufacturer is pretty comfortable wiring in something like a temperature sensor or a pressure sensor. So really the idea was, okay, can we provide some actionable information, some kind of really high level information, but package it in a sensor form? So the person sensor has one pin that goes high when there are any people around. So you can use that to kind of, wake up a larger system like a kiosk or something like that. And then it has an I2 C bus, like most, sensors, actually using SparkFun's Quick system. So it's got quite a, common connector to fit into that ecosystem. And that tells you where the faces are, if they're looking at the device, and also does some simple facial recognition. So we've had people do all sorts of things like a fan that just kind of follows you around the room. We've had a lot of fun with that. Something that actually locks your laptop when you get up and walk away. A microphone that sort of mutes itself when you're not around. And really just, it's been really fun seeing what people have actually come up with. And we have a project hub on Hackster that actually has a lot of the examples of, we even have somebody who's got built something to play Pong with your face, which I'm not sure. I'd probably give myself neck ache doing that, but I love that creativity.
How do you see this integrated from an OEM? Do you expect them to just go implement a module in their system, or run this as part of the current firmware, or how do they integrate that?
Yeah. So it's a good question, because manufacturers are super cost sensitive.
It's $10 BOM edition is expensive.
Exactly. So they're very careful about adding any extra expense. But one of the other things that I wanted to do is, if we're going to be having, I think that there's going to be a lot of reasons to have a lot of cameras and microphones in everyday devices. But I really want to make sure that they're private by design. And our proposal, the way we would like to see things done, is actually by making sure that all of the sensor data is completely closed in the sensor itself. So all of the raw camera feed, the microphone, hopefully all of the things that are potentially sensitive are locked away in this separate module, so that even if the system gets hacked, or if you don't trust the the manufacturer entirely, You've got some guarantees that nobody can actually access the camera or the microphone to get access to those pictures or that audio. So it's definitely, something that manufacturers, kind of choke on a little bit, I would say. But I do think that the privacy side, or I'm hoping that the privacy side really makes sense to them in the end. And they do want to adopt, this separate module, even though, it's a little bit more of a pain for them because it gives their users more privacy.
So an interesting remark on I think back in the day when I was doing IoT device without any ML smarts, 2014, 2015, one of the things we wanted to roll out in our office was peer motion sensors on their desks. And we had the same argument, right? Like it's only local, it's only processed there. The only thing we send over is either a 1 or a 0 if someone has been there in the last 10 minutes, so not even real time. But the backlash of that, of just the idea of like, hey, there's something under a desk which has something that resembles a camera, right? It's a peer sensor, but that backlash was huge, and we could kind of all the guarantees that we would give about this only stays local were really hard to counter.
And one of the things that we're hoping, because I didn't realize, I mean, it totally made sense once I discovered it, but when we were talking to industrial companies about uses of this, one of their big concerns was, the unions are actually very, on the ball about making sure that their members do not get spied on. So a lot of what we found is stuff comes down to, are people actually seeing some benefit from this stuff? Or is it something that's kind of, a surveillance tool being used for, somebody else's benefit so that they can, keep an eye on whether you're busy at your machine or not. So we're really trying to focus on use cases where we offer something that's helpful to the, to the end user versus, things that are only helping out the, the manufacturer. But yeah, I hear you, Jan. It's something that we're really having to explore. Like, what will people accept? Like, what will people enthusiastically adopt because it gives them something that they want? And that's really what we're trying to focus on.
I'd like to add, even way back in 2014, if that was the case, where now it's more, people are more aware and stuff like that. And I think, having the bare minimum of, at least guaranteeing that no data is leaked, that's like almost a starting point, right? We cannot even have anything worse than that. So that kind of means that we are on a good or a right direction.
Yeah, I love the sound of a future where people's assumption is that data isn't sent anywhere as a baseline. And then you have to make a very compelling argument as to why you would want to send data anywhere versus where we are right now, where the default is that stuff happens off somewhere centralized.
Right. Well, we actually have a couple of questions coming in now. So the first one looks to be, can the user change the firmware on the person sensor?
No. And this is actually quite a common question, and it's something that we because we're so focused on the privacy side of things, we really have tried to do everything we can to make sure that nobody can kind of swap out the software that's running on the device once it's left the factory. Because, we want to be able to get third parties to certify, hey, we've looked at, we've evaluated this and it doesn't leak any data to the rest of the system or the outside world. And that gets very hard to guarantee. What I would suggest, though, is, I love Edge Impulse for this stuff. I love using things like the Pico and the Raspberry Pi. Pico and RGCam have a great Pico 4ML module. I think there's a lot of great solutions out there if you are somebody who's got the experience and the enthusiasm to actually write your own code around this. We're very much aiming this at people who just want to get a capability off the shelf. Sorry, but it's very much designed to be a fixed purpose device.
Okay, and that actually leads nicely into our next question. OEMs need a privacy banding they can stick on their device to offset the privacy worries. Do you see any certifications now or in process that your products will aim at?
Yeah, so we're actually working with a company called Kudlur, who have a lot of experience doing certification of security around IoT devices. And we're working with them to, figure out how, they and potentially other third parties, like I'd love to get Underwriters Laboratories involved, for example, or even, it's not really what Consumer Reports does, but, it's kind of organizations like that. And actually, see if we can come up with kind of industry-wide approaches to being able to test all these devices that are in our home. Really one of the motivations for me on this was that people, when I was at Google, especially when I was working on the voice stuff, a lot of friends and family would ask me, hey, I was just talking to my friend about Tunisia and I'm getting ads now for holidays in Tunisia. Is Google spying on my conversations? And I would tell them no, but I can't prove it because it's so hard for anybody who's not actually at Google to really figure out, and verify exactly what's happening. I'm very, very keen to figure out, both for us and generally across the industry, how can we get third parties in a position where they can verify these claims about privacy?
Excellent. Oh, here's a question for the ages. When will the board come to stock again?
I know. All I can, my only excuse, first off, starting with the excuses, I'm a software person. I didn't realize how hard getting hardware manufactured was. We are hoping we should have some stock going to SparkFront hopefully early next week. I believe that's all already spoken for with back orders though. So we then have a much larger order, a much larger batch that should be coming in about 2.5 weeks, I think. And hopefully that will be enough to clear the backlog and make it so that it's available easily. And then we're just
in time for holidays.
Yes, exactly. We want to have some fun. We did some Halloween projects, but they were only just in time for Halloween, like our spooky eyeball. But I'd love to do some. I don't know if we can do some turkey or some Christmas or some New Year's projects. We'll have to think about that.
How many did you manufacture until now?
We've only been manufacturing, basically I think we've got about 2,000 in the pipeline. So those should be coming through over the next few weeks, and hopefully that will clear the backlog, and then we're just going to keep kind of manufacturing a few more thousand. Honestly, a lot of the delay on this stuff is just we've been figuring out which PCB manufacturers to work with, trying to source all of the components. And that's a whole new world that I think none of us had really worked with before.
Yeah, so back when I did my first hardware run ever, 10 years ago or something, we were in the factory with the pick and place machine set up. And the moment that we get the boards out of the pick and place machine, the first one, we try to hook it up and we can't program it. And only then we realized that apparently we forgot to hook up the power and ground lines to the JTAG. So we had a lot of PCBs that we couldn't program. And it was a Nokia factory in Norway that also makes a lot of the Nordic semi dev boards. So we tell this to the guy, and like they start talking Norwegian really, really fast. And all of a sudden our whole box of PCBs like gets moved to this desk. An elderly lady is sitting there. She's gonna sit behind the microscope station. And she just starts fixing all of her boards, like 500 of them in 2 hours.
Well, we've been having flashing parties, and actually also because we have a connector that we snap off that we use to program, because we want to physically make it as hard as possible to sort of tamper with. So we actually, we have all these broken off tabs in the office, and we just kind of sit there and snap stuff off. It's crazy because I've never done hardware before. And it's so different than deploying software.
I didn't even know such a thing was possible to kind of do that. Can I mention, Rob, you missed like a comment, which is more like also a question right before like the one about stock. It says privacy can be addressed by making the hardware open source. I think that's worth addressing too. Yeah, I can take that. I mean, yes, I think, I don't know if Mike H, you meant like making the device less private, but make it open source, or make it as private as it is now and also make it open source. If it meant the second, obviously the answer is yes. Yeah, we should, we there is nothing, I mean, other than the, if at all, something is like proprietary, it's the machine learning model, but otherwise, the hardware, the schematics and so on should be easily made open source.
The hard part with this kind of stuff is, yeah, sure, it's open source, but how do you even verify that what's on the board is the same thing as is in the open design documents, right? That's the
and one of the way, because there's always going to be possibilities of doing things like, oh, we somehow figure out a way to smuggle out an image one bit at a time by toggling the clock line or something on I²C. And part of the way we think about this is it's like we're trying to have a list of ingredients, like you would have on like, a candy bar or something. We're saying this is the only thing that we will release. And then there's a whole different way, there's all sorts of different ways of kind of checking that. And there's also, because we're making this promise about what will be released, we've actually got some accountability on us, so that if people down the line, it's not like a privacy policy that everyone has that's basically we can do anything with any data and give it to anyone, and then you just kind of like check the thing at the end. We're trying to say, hey, these are the only pieces of information that we're going to be passing over, and hold us accountable. Like, there are lots of different ways of checking that we're actually doing what we say. And even if it's not theoretically computer sciencey perfect, at least it's an improvement over where things are at the moment.
Right, and that's always a fine line between open source and privacy. Let's see, we've got a question. We have a question already. Oh, and if it makes anybody out there feel any better who hasn't gotten theirs yet, I haven't been able to get mine yet. I work at SparkFun. I haven't been able to get mine yet. But we have questions already about version 2. When can we expect a version 2, and what plans do you have for it?
So we're actually, one of the things we're trying to figure out with the person sensor in particular is what people most want to use it for. One of the things that's come up is we've really designed it to be something that's usable within a couple of meters of the device, and when the person is facing. So we're looking for faces, and the sensor really, works best within a few meters. We've actually had several people coming and asking us about things like, trying to do asset tracking, or trying to make sure that people aren't, kind of in an electricity substation when they shouldn't be, because we don't want them to get like electrocuted. And and actually one of my favorites is I'd really love to build a robot and have it use a person sensor to follow me around. But right now I would have to be facing the robot, the little robot with wheels or whatever, for it to come towards me. As soon as I turn my back on it, it would no longer, spot that I'm a person and follow me. So V2, some of those requirements are pretty interesting. I do have to say, though, we're actually looking at doing a gesture sensor as a hand gesture sensor as the next thing we release. So we may not get round to version 2 of the person sensor.
Radar or?
No, actually doing computer vision.
Okay, vision, yeah. How out of curiosity, like how big is your data set and how much of that is collected and labeled by you compared to open sources?
I'll let Manjunath.
So for the person sensor, we mostly used open source data sets. There's a bunch I can point to you later, but we did like fine tune the model later with a couple thousand images from the camera. But for the gesture sensor, it's really hard to get data for gestures. So there's like a few open source ones, but mostly they, deal with static gestures and not like, videos of people doing things that we would like to see on, things like TVs and so on. But yeah, we are focusing on those open source data sets. We always, collect data from the camera to kind of fine tune it later. But so far for the face model, we just trained it on a huge collection of open source ones, and then later fine tune on a small set of images from the camera. And it seems to work well.
How do you deal with like one thing we run into when dealing with like even stuff that is considered kind of state of the art, like Common Voice or something. Like the moment that we go in, there's a lot of trash in it. Like, do you have any like cool stuff that you developed internally to detect this stuff and kind of find low quality samples?
Sorry, which data set are you talking about, or in general, you're talking about like noise?
We've done a lot of work in Common Voice, right? I don't know what data sets you guys are using, but do you have built some cool internal tools to help you assess data set quality, or?
No, we haven't had time, and definitely that's something that I don't have to just like preaching to the choir, but this data is the most important thing in all the work we do on the ML side. So far, we haven't. So we have done a lot of work on taking models and reducing their size and so on, but just run it off of open source data sets as is. But this is obviously something that we have to kind of start looking at soon.
And I will use this opportunity to plug a startup that I've been advising for the last couple of years called Galileo at rungalileo.io, because they do a really good job of actually helping identify those kinds of low quality samples in your data set in a very automatic way. At the moment, they're focused on like NLP data sets. But I'm trying to encourage them to sort of move towards some of the image stuff too.
Very nice.
Yeah, this is a big thing for us as well at Edge Impulse. So how do you let people understand the quality of their data sets and do the kind of sampling and analysis that a data scientist would be able to do, but without having to go away and spend a few years learning about it?
Okay, this is not a question, but this is a shout out I think is worth repeating. Jan, I'm a big fan of you, your techiness, your name, and also your hair.
Oh. Me too.
My video freezes straight away, so
Yes. Well, here's another one for useful sensors. What other boards do you plan on releasing? Gesture, thermal or IR, sound, or KWS?
So I think the two main ones that are on my mind, and on the roadmap are the hand gesture detection, just because we've had a lot of people who would really like to do that, and actually doing voice recognition. So having a simple, cheap board that you can buy to add voice recognition to your projects and products. There were loads of others that I would love to build. I would love to do sort of pose detection, human pose detection. I would love to do, we've often talked about doing automatic text and number recognition in images. So you could have a sensor that has a camera on it, and whenever you pointed at any text or a QR code or a barcode, it would actually then just send that over kind of like a UART or something like that to the microcontroller. And I'd love to have that as a way of kind of automatically reading, water meters. Honestly, there's so many things I would love for us to be working on. But right now, the hand gesture and the voice are the two main ones on our roadmap. So go ahead.
Oh, go ahead.
I was going to say as well, actually asking about thermal and IR, we're very, very focused on computer vision type stuff at the moment, just because we see that as being able to solve a lot of problems, even things like audio related stuff. We're looking at doing kind of lip reading to go alongside the microphone inputs.
And I feel like Go ahead, Daniel.
Oh, sure. Sorry. I was going to say, like, how do you figure out where you want to be? Like, what the space of possibilities is so big. We have this same problem too, where it's like there's a billion amazing things we could do, and you do want to be guided by your customers and potential customers in what you build. But a lot of the time, there isn't the awareness out there of what's possible. So it's hard to judge by what people are asking for, because sometimes people don't even know that something's possible and that they could ask for it. So how do you kind of approach that?
Yeah, I mean, and honestly, that's kind of tricky. Part of it is just honestly, part of it just comes from projects that I want to build. I like as kind of a maker. There's things that I would love to be able to put together, but also, we're spending a lot of time talking to manufacturers, and really just trying to listen to what they're telling us about, hey, we would have loved to have launched this feature, but we couldn't because, X, Y, Z. So I'm trying to be a bit rigorous and disciplined about actually listening to customers, so I don't end up kind of leading us into kind of a whole bunch of really neat toys that don't actually have any commercial potential. But yeah, it's tough.
I think the fun part of doing a startup, because we've gone through this same exercise as well, right? I think the fun part of a startup is it's a journey where you have no idea where you're going to end up. Like for us, our biggest market segment commercially is in health. I would have never imagined that when we started Jimpulse. And now all of a sudden I know more about sleep and glucose and stress monitoring than I've ever thought I could have known.
Yeah, and I just read an article out of Stanford about a team working on exoskeletons using Edge Impulse to assist in walking. I thought that was amazingly cool.
Amazing.
That's super cool. That's the exciting part, when it gets to the point that there's people doing stuff with your product that you've never even thought of or heard of and don't barely understand, and people are telling you about it and you didn't even hear about it.
Right, I'm reading about Edge Impulse on WebMD. I thought it was amazing.
It's really cool.
Man, so we had our conference the other a month ago or something in California, and I got this email from just a random email from a guy. He really wanted to attend. So okay, fine. It was invitation only, but we extended invitation. And this guy just comes to the conference and he's wearing his own shoes, like 3D printed. I'm like, wait, what the fuck? And he completely designed the electronics to be in the sole of the shoe to have Edge Impulse compatibility, so it could detect your events and train stuff. And I was like mind blown. Like, it's so cool if you build this platform and people just go build stuff on top of it that's just mental. It's probably the same with you guys. All the stuff that you guys see on Hackster now is stuff that you would never have imagined.
Right.
There's even
Absolutely.
someone in the chat here. Somebody, it was Debashish, who says they were lucky to receive their sensor during the initial run of hardware and was able to make a face following Skull for Halloween.
Oh, I would like to see a video of that.
That's
Yeah.
awesome.
Yeah, that would be fantastic. I'd love to check that out.
I think we have a lot of questions. Maybe we should go back to those and stuff.
Yeah. Let's go to from Rich with voice detection. Could it also be used for sound detection for things like running water, fan noise, things like that?
So we did actually have some people asking us, especially for flood detection and water detection. I think that's because it isn't clear. Like a lot of our challenge is we need to find use cases where it makes sense to be able to have like large scale and have something that's really cheap. Because for it to be really cheap, we need to sell a lot of them for it to make sense. And what we've struggled with some of these, use cases like water running and fan noise and things, is that they often require kind of a lot of specialization. One of the things I point people to Edge Impulse all the time because Edge Impulse actually has really good tools for putting together custom models to address kind of more specialized needs like this.
So a really interesting site, sorry for plugging a different company, but we're working with a company called PolyN. And what they do is sort of a similar approach. They have a piece of silicon, audio front end and whatever, and they run noise cancellation, like typical stuff you do in audio models. But then what comes out is not a conclusion, but rather embeddings. And then on those embeddings, you run like a really small classifier, and they handle all the low power stuff, the activation of the microphones and stuff, which is a really interesting combination. So maybe something for useful sensors to consider at some point. Because you have the privacy benefits, like the stuff you never get the raw audio, you just get like a really good quality embeddings out and you train your stuff on top of that.
Yeah, one thing I'm excited about personally is that we've got this whole ecosystem forming around embedded machine learning. And like I've just been working on this book, it's called AI at the Edge, that it's me and Jenny Plunkett from Edge Impulse we've been writing. And it covers, everything that you need to do to build an Edge AI project. And there's so much stuff that's like technical, and there's like soft skills stuff and collecting data sets and building a team. And every different problem within that book basically is something that there's an opportunity for companies to exist to solve problems in. So like we're solving problems for people who want to train custom models and deploy them to devices on the edge. Useful Sensors is solving problems for people who want to do this stuff, but they don't have a team, or they don't want to hire a team to do that kind of thing. And there's so many little niches within the ecosystem that are going to be massive businesses, because this is just going to be a completely pervasive technology. A decade from now, everywhere you look in your home, there's going to be embedded machine learning. So it's cool to see there are all these corners where we can all contribute something and make it easier for people to build this stuff into products.
All right, here's one, and I'm not sure if any of us know this, but when are MicroPython boards becoming mainstream for tiny ML applications?
I mean, it's a hard one, right? So I understand the kind of appeal on the developer side. The hard part with this stuff is that you're probably never going to deploy something on really large scale when still running MicroPython, because you're throwing away money. Like the first thing, if you want to take something to market, like in large volumes, 100K, 1 million devices or something, you're going to look at how can you shave some cents off the BOM. And the easiest way is actually going from the thing that you're developing on to a cheaper version of the same MCU. So in that case, if you can save $2 or $1.50 or something per device by switching out your MicroPython stuff for C++, then that's easy money, right? You win $1 million basically by doing that. So that makes it hard, like, because on one end we're trying to solve this for large customers selling lots of devices, and that's what the silicon vendors are doing too, and those put the developer boards out. So you see this happening, for example, in OpenMV. They do everything MicroPython, really awesome developer experience, but they can do that because they're not targeting the super high-end, high-volume stuff. But the large silicon vendors, for them, it's nice that they do stuff for developers, but in the end they just want to sell millions or billions of MCUs, and the customers that do that are not going to deploy that, so that's why they won't invest so much money on that. I think that's sort of the reason why.
All right.
Dissatisfactory answer, but here we are.
Here's another one. Do you have any sensors which can classify the car type, for example, hybrid, electric, or Bunsen, using edge computing and number plate of the car and using edge computing, and it will be forwarded via LoRaWAN or other technology considering data privacy?
So the text recognition sensor I talked about could potentially be used for, reading license plates. I think the other sort of classifying, detecting cars, classifying types of cars, that might actually be more in, Dan and Jan's world with Edge Impulse.
Yeah, I think we actually have a example out there with identifying different models of car with
I don't know if it's
camera.
public. We have a commercial customer who's actually doing stuff like this, but it's a hard problem to solve. So there's all kinds of stuff, especially if you want to do this battery powered. It's, I think, an interesting question of Vinay also in the chat about like power consumption, especially when you think about this stuff. If you want to put a car and license plate detector somewhere on a tree and then like go monitor that, how do you make sure that it actually runs on battery for a while? So there's all these kind of like secondary sensors that you use then to actually trigger, hey, this is the moment that you need to wake up. So if you look at kind of the potential cases for useful sensors, I think, then this is a really hard one to go solve.
And I feel like license number detection is going to start to eat into the privacy concerns, because we're having access to the database of license plate numbers. If you had that, you could easily figure out what make and model vehicle it was, but that means, putting it all out there, you're not on the edge anymore, you're out in the world. Oh, and speaking of battery, like you just mentioned, can we expect the low power consumption in the future? Where'd that one go? In future improvements for battery run devices?
Yes, I would love to, at the moment we've really focused on, just getting the first version out. I think that there's so much of a future in low power battery powered devices. We're 150 milliwatts right now. I would love to get that down to sort of below a 1 milliwatt. It doesn't seem, like that should be crazy. I think we just need to, prioritize the engineering work when we're starting to see, customers and use cases that want this.
Right. For us, one of the biggest, we just did a nature camera together with Conservation X Labs. The biggest thing there is just add a secondary sensor, peer motion, and then just be asleep and then just wake up the actual camera. That stuff just helps tremendously. I don't know if you guys are thinking about that. I think it will work really well for stuff in TVs, stuff where stuff doesn't change so much, living rooms, whatever.
Yeah, definitely. I think the HiMax, has a lot of capable. HiMax MCU has a lot of capabilities for that. I mean, it's again not surprising that we're always looking for more compute at lower energy and cheaper cost, right? I mean, that's always the direction in which we are going. So, yeah.
Yeah, I'm always really interested in what you can do with this type of stuff at the application level. Like, if we're thinking about trying to fit within certain design parameters, like what frame rate do we need to run inference at? Because for like a wildlife camera, you don't necessarily need to run inference on live video. You can do it after an image has been detected and captured and stored. Whereas for some applications, you need real-time, tracking of someone's head while they're having a fan follow them. So all of that stuff that's very application specific, you can use to tune things down to the point that you want.
If anybody's interested, there is a link now in the comments to the license plate recognition use case, which is really cool. Here's another one. Are you looking into providing accessories such as 3D printed enclosures to house the person sensor along with the popular microcontrollers or battery? Or is that going to be more left to the open source world, the rest of us?
I'll let Manjunath.
Oh yeah, I would like to see it nicely packaged up, and the biggest thing for us is the cost. So we might consider like putting out like the files for 3D enclosures and so on for the popular 3D printers, but so far the plan is just have the naked PCB out there.
I know for us at SparkFun, a lot of times we don't have time to create a housing in 3D or laser cutter. If I have to do a quick demo project, I'll whip something up, but it's usually pretty close to junk. It's just something to hold the components so that I can demo it without having to hold them in my hands. But we've seen a lot of work from the community. People will buy our sensors and then say, oh, look, I created this 3D housing for it. And they'll share that with the world on Thingiverse or wherever else, on Prusa's new 3D site. So yeah, they are out there.
Yeah, and if you check the projects on Hackster that I did, you'll see I'm using like blue tack to kind of hold the sensors in place, which because I am terrible, like I said, I'm terrible at hardware. I can barely solder. But we actually have some people on our team who are really good at the 3D printing stuff and have put together some really nice housings. Maybe one thing we might be able to do, Manjunath, as I'm thinking about this, is see if we can open source. Like, we have something that you can put a little board in and then plug into the side of your laptop as a USB key to hold the person sensor. Maybe we can make those, those 3D printing plans available if people want them.
So one tip, Pete. This is how I learned how to solder. At some point, we were supposed to run a demo at a conference, and I ordered a bunch of boards with these super bright multicolor LEDs. What do we call them again? Probably from SparkFun, actually. Yeah. And they came in at 4 p.m. on a Friday, unsoldered. And someone in the ARM office pointed me at the lab, and he's like, "Yeah, we got a soldering iron there." And I spent my whole Friday night watching videos on how to solder.
Oh my god!
I managed to get every board working. So.
Panic is a great motivator.
Yes. Oh my god.
Oh, this is an interesting one. What about latency?
Yeah, I think the person sensor runs at 4 frames per second. I don't know what you mean exactly by the question. So, the I2C has whatever its bandwidth is, and that's we only use I2C for communicating. So it if you're talking about the latency of the model itself, if it is 4 frames per second, it's something like 200 milliseconds or whatever. Does that answer your question?
So definitely fast enough refresh rate to track your face with a fan.
Yeah, that should be sufficient for the applications we're looking at.
Also, with this kind of stuff, like even we've done a bunch of work on the IMAX WI Plus, the same module you guys have been doing. It like stuff you take for granted on your phone or something, or you just get like a reliable 60 frames a second stream of data. That is not the case on a lot of embedded vision elements. So.
Yeah, that and the size, 2 megabytes is like hardly sufficient for anything. So.
All right, what else have we got? See, I know that we touched on it before, but let's talk about the synergies between ML sensors and ML ops tools like Edge Impulse.
Yeah, absolutely. I mean, I think, like I was saying earlier, there's this sort of different buckets of different people who need different things. And I think there's kind of the natural companies or teams that fit into a place where they can use something that is static. They have the right kind of use case and they don't need customization. And the benefit that gives them is that they can avoid having to bring on all the expertise required to develop and create models and integrate them into hardware and so on. And then there's kind of the step up from that where you don't want to, bring on an entire deep learning team of experts, but you want to be able to build really cool stuff and deploy it to edge devices. And we sort of cover there on up through to the point where you've got a big team of deep learning experts and they need to be able to work together with all of the other parts of the company. So I think there's just this continuum and there's this like blurring on the edges of like maybe you start to like run into the friction points of the solution you've got currently and you need something a bit more flexible, or as your product evolves, maybe you want to change things. I think there's going to be a lot of jumping from one solution to another depending on the context.
Yeah, I used to joke. I still joke. It's like why is every IoT device as a temperature sensor connected to the internet? Well, because you can buy it on DigiKey and then it gives you this one pin, like what Pete said in the beginning of the conversation. But I think and so that's one end of the spectrum, right? There's something, it's very simple. A complete sensor is there that just does exactly the use case of what you want to do. Then at the complete other end is you take a random microphone and you train an image impulse to go detect, water hammer or something, like something really specific for your use case. But there's a really big kind of gap in the middle, which is very common stuff that you want to do with audio or images, like person detection. There's no reason for everyone to go build their own and collect their own data set and build their own person detector for stuff that is so ubiquitous. That should just exist as something I can buy off DigiKey. So I think this idea of like right now the only thing we can do is really specialized sensors towards useful sensors is going to take stuff that we can do that we can very easily perceive visually or audible and put them into the sensors, like make that whole thing bigger. I think that's really good. And then we're going to push on the other side. And the end goal is that in 10 years, everyone will use some embedded machine learning in their devices.
The cool thing that you get if you've got both is you can even use them together. So you've got a fixed sensor that can tell you when a person is in front of the camera, and then you can collect data about when people are in front of the camera and where they're moving and what they're doing, and use that to train another model which interprets that information and makes use of it. So it's not even a sort of either or thing. These things can play nicely together too.
Nice. Here's an interesting question, interesting point. How about adding PWM output on the interrupt pin to know how many detections instead of just a wake-up pulse? That way it would be useful without a host MCU.
Yeah, I love that idea. I've been learning more about PWM as I've been sort of starting to play with servos for the projects. Especially if you have, it really helps to have concrete use cases that you can share, where you'd be able to tell us, hey, I'd be able to do this if you could give us PWM output. Like that would be great. So please, get in touch. I'd love to hear from you.
And I will say, knowing Pete for a few years now, I think the first time we worked together was it was in 2019, right before the world shut down.
Yes.
Yeah, we did a little ML stuff together. But yeah, when Pete says reach out to me and I'll get back to you, he means it.
Yeah, actually, put Pete at Useful Sensors on the on the chat. I'd love to hear from you. If you have questions that weren't addressed here, or just if you have, hey, we've got a use case, or we've got a product, or we've got a project, I'd love to hear from you. So
Yeah, similarly, someone asked before or commented before that the sensor in low light conditions is not very good. I would also like to hear from them. If you can get in touch with Pete, I would like to at least get, if you don't mind, like sample images that had poor detection, and we're always trying to improve the model.
Yeah, thank you, Manjunath. I missed that one. I saw it go by, and then things got busy, and we got sidetracked. Thank you for picking that up.
So how is it for you guys to start a new company, and how overwhelming is it? Is it fun? What is your take of all of this?
It's fun. I have developed a tick in my eye that I feel like I'm trying to remember the name of the like Inspector Clouseau's boss in the Pink Panther movies. I'm feeling a little bit like that. Like it's fantastic. It's so good to actually see stuff out there and see people using it and hear about, just like you are with Edge Impulse, like seeing things that you just didn't even know about or even imagine that people were able to do with this stuff. Like, honestly, that's the most satisfying thing. But it is all a little scary when you're just trying to do something from scratch.
I think I've had that same eye thing. I know what you mean. Yeah. It's a startup eyelid.
Yes.
No, it's been fun, Pete is great. Working with him was amazing. And, the thing for me was like the thing that, so I wasn't, doing a lot of TinyML before, but I was always a compiler person in my life. With the thing with compilers is you need to kind of understand the both sides of the thing. Like, you need to understand the applications and you need to also understand the hardware. And TinyML is exactly that. Unless you kind of understand the whole stack, starting from the machine learning model to the application that it uses it, and to the MCU or the device it's running on, you can't really come up with a compelling solution. So when Pete said this is what he wants to do, it's almost like a no-brainer for me to jump in, because I had like this similar attitude towards like optimizing in their stacks. So that way, technically, it's been really exciting. And also on the the startup side, really maybe I shouldn't jinx it, but we haven't had like really sleepless nights or whatever working on things. We have been taking it like at our own pace, and but actually enjoying it.
It's funny. Back in 2021 or something, I think after we raised our Series A, I sat with my co-founder Zach, and I was like, "Is this startup thing supposed to be really hard?"
Yeah.
Trust me, it will get hard. Like, we're 70 people now. Holy shit! There's all kinds of stuff that you're normally shielded from, or that you just don't have in a small team. But it's a good problem to have.
Yeah. And I will say, so go ahead, Rob.
I was just going to say, I can tell you that we still get eye twitch here, and we're about to celebrate 20 years. So get used to that, my friend.
Yeah, and I was going to say, it's been so good working with the team. I'd worked with Manjunath for years before. A lot of the other members of the team I've worked with before. Some of them I haven't, but it really has been a dream. They've been so, it's honestly, I feel like, this is the first big role I've had where I've not actually been coding, at least as part of it.
But you code now. I don't know what you mean.
Well, that's the thing. I broke my promise. I've actually been doing the example code, but it's been I've had to sort of step back and let Manjunath and the team kind of I haven't had that hands-on experience with the code, and honestly, they've blown me away. It's been just so amazing seeing how fast and how good the results that they've been able to produce are. I've been so happy and grateful to see that.
Cool, thank you. I have to say, this has been wonderful and enjoyable, enlightening. I want to thank all of you for being here. I want to thank everybody who's been out watching and joining. And again, if you have any questions, you know where to reach all of us probably. And I personally am really excited to start playing with this sensor, see what sensors are coming in down the road, and continue to work with all of you.
Thank you so much, Rob.
Anybody have any wise words of wisdom?
I wish.
Yeah.
Excellent. Well, all I can say then is thank you again for joining us. We look forward to chatting, working with you, and seeing what you all create with useful sensors, with Edge Impulse, and with anything you might pick up from SparkFun here.
All right. Thanks. Bye.
Cheers, everybody.
Thanks,
Thank you so much.
Bye.
Bye, all.
Bye-bye.